Okay. So, of course, you know the original question is, can you hear? Can you see? Is the screen the correct size now? All of that. Okay, so you can hear, the screen is the correct size, and so on. All right, so let us finish with that first problem. All right, so let us finish with that first problem. Thank you very much for your prompt response. So I'm sure that you are seeing now. Let's continue. All right, so what? May I find my marker? Yes, I can. Alright, so yes, let us finish. And of course, you can see right here, all we have is 81 minus 80 over 45. And let's write that. 1 over 45 for your final answer. As I said before, the numbers might be a little bit different in our books. If I can find my book, yes I can. So let us look at our number 2. Students, when you are solving or given a problem like this to solve in the examination, do not separate the problem into 3 parts. Keep them together in the same way that I'm doing here. So 5 1/4 minus 2 and 1/3 over 2 1/2. Of course, we have taken a good look at it. You'll see some strange things happening in the long run. Not so strange, but things that could be to your benefit if you take a second look at the problem that we have there. As we say, what? 2 takes longer than 5. And you'll understand what I mean when I say 2 takes longer than 5. You will understand that in a few. So let's go. Improper fraction. 4, 5, 20 plus 1. That will be 21 over 4 minus 3, 2, 6 plus 1. So that will be 7 over 3. And we're using the width of the page. And we're going to divide that by, all of that by 2 2's 4 plus 1. 5 over 2. If at any stage you don't follow something that I've done, let me know. Sir, I do not understand. What is it that you do not understand? You do not understand how to convert these into improper fractions? Oh, this one, I have to start over this one? I know that you're not telling me to start it over because it was far-fetched. I think that you're telling me to start it over because you started the class too late. No, because we had all of that difficulty let me go it over nonetheless. Now, what I've done for this first step is I've converted all of these numbers, mixed numbers, to improper fractions. I've converted all of those to improper fractions. Do you understand that? How to convert those to improper fractions? Okay, so that's what we have done here. We have relaxed these parentheses because these are not necessary. They are not necessary because the parentheses are telling us to divide before we subtract. But in the normal mode of operation, we generally divide before we subtract. So we don't really have to have that. So there we go. Now what we have done here is that we are dividing by 8 over 3. And when you divide by a fraction, you do the reciprocal and multiply. So you do the reciprocal and multiply when you are dividing. And of course, when we have done that, we realize that we have common factors. So we simplify by the common factor. So we have 24 over 5, and we are multiplying now because we are going to do the reciprocal of this, 3 over 8. And immediately you see 8 into 8 is 1, and 8 into 24 is 3. No further simplification. 3 times 3 is 9, and 5 times 1 is 5. Then we are going to subtract. And if I say add, it would mean the same thing because you understand from directed numbers that subtraction is merely adding in the negative direction. So here we have 9 over 5 minus 16 over 9. When adding or subtracting fractions that do not have the same denominators, what do? We find the common denominator, which is the lowest common multiple of the two denominators that we have here. That's what we normally do. However, when these two numbers do not have a common prime factor, the process is very simple. So let us do the process, which is very simple. And you will see that in the other visuals. So I'm going to put up some fraction manipulating other visuals on TikTok. Make sure you watch them. Of course, as a matter of fact, these same problems that we are solving now will be placed on TikTok so you can see them. I wonder if they're so long. I think that they are long. Well, I guess that I've divided them into smaller audio visuals. But let's see. They'll be able to go there if they are just less than 10 minutes. So you'll have quite a few of them to take a look at. So ensure that you pay attention to them. So let's go. There's a simple way. When they do not have common denominators, we say 5 nines, 45. 9 nines, 81. And 5 times 16 is 80. So we say 5 nines, 45. 9 nines, 81. 5 times 16, that's 80. And of course, 81 minus 80 is 1. So it is going to be 1 over 45 for your answer. You're welcome. Here, all that we have done here is converted these to improper fractions. And of course, we don't want to keep the expression too hilly in order not to exhaust vertical space too quickly. So what we do is we put the one that we are dividing by, we put it at the side. But we have to have all of this enclosed in parentheses to show that it is not only, because if we did not have the parentheses here, it will be saying that only the 7 over 3 will be divided by 5 over 2. But when we put the parentheses, we are saying that the entire thing is divided by 5 over 2. And of course, you know this one, we can run this out very quickly because there is no common denominator here. Sorry, let me say that again. There is no common prime factor right here. Because there is no common prime factor, what do we do? 4 3s, 12. 21 times 3 will be 63. And 4 times 7 will be 28. And of course, we're going to multiply by 2 over 5 because we are dividing, so we multiply by the reciprocal of the denominator. And of course, we're going to subtract. 63 minus 28. So it's going to be 8 from 13 is 5, and it's going to be 2 from 5. So when we do that subtraction, we're going to get 35 over 12 to be multiplied by 2 over 5. That's nice, because although the numbers look a little bit awkward, especially the 35, when we do a little bit of simplification, it turns out to be just 7 over 6. So 5 into 5 is 1, 5 into 35 is 7, then 2 into 12 is 6, and 2 into 2 is 1. And that's all we have. That turns out to be 7 ones, 7 over 6 ones, 6. Number 3. Of course, you don't imagine that I'm going to do every single one of them, but I'm going to enjoy this as much as I can. Now, students, take a look at this problem. What do you see? The one that I have for number 3. 3 and a third multiplied by 1 and 1/5 over 3 and 1/3 minus 1 and 1/5. Now, of course, students, you're going to learn this strategy. Thank you very much. You're welcome. All right. So, yes, let's continue. Whenever you have a problem to solve, students, take a look in order to see if there is anything that makes it simple. Yes. Take a look to see if there is anything that makes it simple. What makes it simple is that the fractions here and here are the same. So if you figure these two out, then these two, you just write them down. So let's go. 3 3s, 9 plus 1, that's 10. So that is going to be 10 over 3. 5 1s, 5 plus 1, that's going to be 6 over 5. Then we're going to divide by, and of course the fractions are the same. 10 over 3 minus 6 over 5. So I'm sure that you're hearing me, but let me know if you're still seeing me. Thank you very much. Thanks. Okay. So look at this now, students. Look at this. Students, mathematics is one of the greatest life skill subjects. I don't think it's the greatest, but I think it is one of the greatest life skill subjects. Right? My impression is that history and literature are greater than mathematics. That's my impression. Right? Because I've read all three of them extensively, so I can tell you. All right. But let's say mathematics. What about mathematics? It's something that is embedded in this simple problem. Thank you very much. It's something that is embedded in this simple problem. First of all, you're going to see that these two are the same. So you just do this and then copy the figures right here instead of doing them over again. Well, as long as you have done them the right way the first time, then you're on. What else? Well, you are going to look here and you can see that 3 into 6 will give you 2 and 5 into 10 is 2. So this is merely 4. And you say, yes, this is merely just 4. It turns out to be, that is so simple. We are going to be doing something with 4. But I'm not going to do that. I'm not going to take advantage of the fact that this thing simplifies just to 4. I'm not going to do that. I'm just going to continue with it. And let's see if anyone can figure out why I am not taking advantage of the fact that this simplifies so beautifully. So I'm going to write it. 6 tenths 60 over 15, which is still 4. And then we're going to divide that by, of course, you know what we're going to do here. They do not have any common prime factors in the denominator, so we say what? 3 times 5, 15. 10 times 5, 50. 3 times 6 will give us 18. So we have now 60 over 15 to be multiplied by 15 over 50 minus 18, I think that is 32. Now students, can anyone see why I did not do, why I didn't simplify this to 4? Well, if you did not see that at the instant that I neglected it, I think that you should see it now. Because I understand that we're going to have a 60 over 15 here. The common denominator here is 15. We're going to do the reciprocal. And when we do the reciprocal, the 15s will cancel. It is good if you can see things before they happen like that. That will make your life easy. And when you're solving a mathematics problem, do not just look at the present. You should be able to look at the past and the future, the present, all at once. And that is known as sequential logic. That is known as sequential logic. Your logic, students, must not only be combinational, but it should also be sequential. Combinational means that it is dependent on what you see right in front of you immediately. That's combinational. Sequential is that you see what is in front of you immediately and you are capable of seeing the future steps. That's sequential. So we eliminate the 15s right away. And what do we say? Is it 4? Yes. 4 into 60 is 15. And 4 into 32 will be what? 8. So your answer is 15 over 8. I'm sure that we have some more interesting problems to solve. I think that number 4 is one. Yes, it is. That we will have some amount of fun with. And no doubt, number 5. And I can hardly see a problem that does not have an interesting twist. So let's continue. Number 4. Let me rewrite this so that it looks more like 4. Students, the 4 must be crossed like that. Do not write a 4 that is not crossed. Don't write something like this and say it's 4. That's not 4. And some people don't even go as far as that, they write it like that. Your 4 must be crossed. And of course, I think that you notice that all of my 8s are closed. And your 0s must also be closed. And your 7 must not be crossed. So let us have some fun now. 4 and 1/3. If you are not focused, students, with this one, you're going to make a meal of it. So let me take a good look at that. 4 and 1/3 minus 1 and 5/6 over 1 and 3/7 times 1 and 2/3. Let's go. Of course, there are two things that we're going to achieve immediately. Yes, of course. Sorry for your delayed response. It makes it simpler if you see that all of those, that large denominator will go away naturally. All right. No problem. Let's continue. So, improper fraction time, students, 3/4, 12 plus 1, 13 over 3. Now, when I'm solving problems, I do not like to see the prime numbers. But let's continue. Minus 6, 1, 6 plus 5. Here's another one, 11 over 6. And then, we're going to divide that by, I think that I'm writing too wide on the board. So it's going to be 13 over 3 minus 11 over 6 to be divided by 10 over 7 times 10 over 7. 10 over 7 times 5 over 3. That's nice. 3, 1 is 3 plus 2, 5 over 3. Nice. Now, students, you have some students who are in this place here. Yes? And while I'm explaining something, they are playing games in the background. That's very nice. When I finish explaining this, and I'm gone now, somebody's calling me, sir, I did not understand, I do not understand. Could you please do that again? No, no bother with it. examination date is set already. So I have to get going with this thing in order that you may be prepared for the examination ahead of time. That's good. All right. So I'm going to explain something to you now. Look at this. 13 over 3 minus 11 over 6. Now students, you have a problem like this, you should be able to do it in one step. In your mind, 13 over 3 minus 11 over 6. Pay attention because I'm not going to explain it again. Thank you very much. Yes. Yes, of course. It's here for everyone. It is just that students are going to be at a disadvantage if you do not have your books. And I will explain that too, especially for the students who are just going through TikTok and they have found this. And it's not very easy to find something that is uplifting on TikTok. Let me tell you, that is why for hundreds and 50 and thousands of years, I know about TikTok a long time ago and I refuse to go on it. But I think that I can use it for good to benefit others, and that is why I'm on it, no other reason. All right, so let's continue. Can anybody see that this is 26 over 6? This is 26 over 6. Because if you multiply this by 2 over 2, you're going to get 2 times 13 is 26, and 2 times 3 is 6. So you should see that this is 26 over 6. Students, if you multiply both numerator and denominator of a fraction by the same number, the fraction is in different terms, but the value of the fraction is the same. Of course, this is 26 over 6. If you simplify this by a common factor of 2, you will get back your 13 over 3. So this is still 13 over 3. If you write it in its simplest form, it is going to be 13 over 3. But if you do this in your mind, multiplying both numerator and denominator by 2, you're going to get 26 over 6. What's the reason for doing that? The reason for doing that is to get the same denominators, so you can go back to your first fraction problem in primary school where you subtract fractions that have the same denominators. So you just subtract the numerators and put it back over the denominator. So this one, we shouldn't do this on the board. I'm just doing it as an illustration. So as soon as you see this, you should know that multiply both numerator and denominator by 2, you're going to get what? 26 over 6. 26 over 6 minus 11 over 6, and you know that it's 15 over 6 that. Then you may go straight ahead with the rest of this. Now students, you can do this in one step because that is done like that. So don't waste the entire evening doing the second part because you finished with that already. So this is going to be 50 over 21. This is 50 over 21. So you're going to be multiplying by 21 over 50. And what do we have? 5 into this is 3. 5 into this is 10. Anything else? Yes. We can leave that. 3 into 3 is 1. 3 into this is 2. So there's no other thing that we can simplify by. Your final answer is 21. How do we get the 21? Because there's only 21 to be multiplied by 1. Everything is simplified to be 1. And then in the denominator, we have 2 times 10, which is 20. So it's 21 over 20. Sure, if the whole Jamaica, as somebody is happy that they found this, Richard James Mathematics Resources. If they know what I know, the entire Jamaica should be on it. Now students, we'll see other problems like this one, where we just look at this and say, the 6 is merely 2 times 3. Multiply both numerator and denominator by 2, changing the terms of the fraction without changing its value, and then do the calculation. We're going to see problems like those again. And we have some more enjoyable fractions in a minute. So let us go to number 5. Is number 5 an enjoyable problem? No! Alright, it should be. And I hope that students, you are being trained to see what how the problem simplifies. Yes, you are being trained to see how the problem simplifies before I start solving the problem. So let's go. I'm going to write the 3 a little bit bigger. This one. Nice. So let's go. Of course, we can see that these two are the same. 6, 3, 2, 6 plus 1, that's 7. So we're going to have 7 over 3 plus 3 over 7 to be divided by 7 over 3. Yes, we know that it's 7 over 3 already. 7 over 3. And I can remember this, I've seen this a long time ago, somewhere else. Multiplied by 10 over 7. Nice. Students, you know what I'm going to do already. I'm going to take advantage of the fact that this is 21 and the common denominator here is 21. So I will not attempt a simplification until the 21 cancels the 21. Because why would you solve a problem when it is solving itself? And you learn you learn many philosophies from me while you're inside this class. Solve the simple problems and let the more difficult problems solve themselves. Hello, Miss Ellis. Let's continue. We know what to do with this. We're adding fractions and the denominators are not, well, they do not have any common prime factor. Because they do not have any common prime factor, what do we say? 3 sevens, 21. 7 sevens, 49. 3 threes, 9. This one looks disastrous. Yes, that 49 plus the 9 and it looks like 58. Gee, I do not think that 58 has a lot of prospects for simplification. But this one says that we are dividing by a product, 70. Of course, we're not simplifying this because we can simplify this. 7 into 7 is 1 and 7 into 7 is 1, but we are not doing that. And of course, we said why we are not doing that already. Because we know that this is a 21 and this is going to be 21. When they turn them up, they are going to simplify, they are going to eliminate each other. So there's no simplification there. So 70 over 21. Neglecting to simplify by a common factor of 7 there. We are not doing that. Then we say what? 49 plus 9. That turns out to be 58. What a disaster. Over 21. To be multiplied by 21 over 70. Oh, we do not like this problem with this horribly large. We know that those will go away. And then what do we say? 2 into 59. If it is so difficult, 58. If it is so difficult to say 2 into 58, then say 2 into 60. So 2 into 60 is 30. So 2 into 58 is 29. You cannot allow the numbers to overpower you. So 2 into 58 is 29. And 2 into 70 is 35. So your final answer is 29 over 35. And as it looks large and out of shape, but that's the correct answer. Now, number 6. Give me a few seconds. As I said before, students, I had a significant mishap before class. And it's a very good thing that I was not operating on the edge of time. As believe me, I would be 10 hours late for class before I go. Could you please excuse me for a few seconds? I'll be back in a second or a third. Thank you very much for your patience. Six. Students, believe me, now is not time to go away from this life. Now is the time for everyone to pay special attention to the life. Now, students, see, we have taken a look at something just now And guess what? We are going to see where it is applicable again. Let's go. Number 6. 2 1/3 minus 1 5/6 and it's beside it now, to be divided by 1 1/3. Lovely. Let's go. Improper fractions time. 3 2s, 6 plus 1. So that is going to be 7/3 minus 11/6 to be divided by 4/3. And I think that everyone will enjoy this one because it's quite enjoyable. Now students, remember this? All you need to do is multiply this by 2/2. If you multiply the numerator and the denominator of the fraction by the same number, it does not affect the value of the fraction. The fractions will be in different terms, but the value of the fraction will be the same. Why am I doing that? Because if I do that, they will have the same denominator and the subtraction process is simpler. So let's do that. We're not going to write it out like we wrote it out on the side. We're going to do it right here. So if you multiply this by 2/2, 2/2, you're going to get 14/6. So it's going to be 14/6 minus 11/6. And that will be 3/6. And then you're going to multiply by 4/3. Is it 4/3 or is it 3/4? Let's take a second look. We are going to multiply by the reciprocal, so it's going to be multiplied by 3/4. Well, we are hoping that it was something else, but there is no difficulty. So 3 into 3 is 1, 3 into 6 is 2, 1 times 3 is 3, and 2 times 4 is 8. And that's number 6. Number 7, students, I'm sure that just by looking at number 7, everyone is imagining, no, it cannot be solved underneath that simple equal space. No, that cannot be done. Well, if I can solve this one in this space, which is about half of the vertical space, then I should be able to solve number 7 down there. Thank you very much. You are saying that you got it now? Yes, I'm very happy. And not only that, but we're going to do some more of that kind, and we'll see how it works very nicely. All right. So number 7. Number 7. 5 and 2/7 plus 3 and 5/7. Gee, it's very hilly, is it? Number 7, yes. 5 and 2/7 plus 3 and 5/7 all over 4 minus 2 and 4/5. Come on, students. I must be losing my head. There's no way that this problem can be solved under here. Now, students, I am sure that for those who are quite attentive, you would have heard this from me a few minutes ago, that 2 takes longer than 5. 2 takes longer than 5. How do I mean when I say 2 takes longer than 5? Of course, 2 takes longer than 5. It is better to take 5 extra seconds to look at the problem than 2 extra minutes to solve it. Take 2 extra seconds to look at the problem rather than 5 extra minutes to solve it. Now students, can you see that the fractions here are 2 sevenths and 5 sevenths? And does that make life easier? It is good that you notice we have a 2 sevenths and we have a what? 5 sevenths. 2 sevenths and 5 sevenths. Two sevenths and 5 sevenths, students. 2 sevenths and 5 sevenths. 2 sevenths and 5 sevenths. That's 7 sevenths. And 7 sevenths is 1 whole. 2 sevenths plus 5 sevenths, that's 1 whole. Then we have a 5 plus 3, and that's 8. So this is 5 plus 3, that's 8, plus 1, and the entire numerator, the entire numerator turns out to be 9. The entire numerator turns out to be 9. Let me take a look at the board from that side. Can you see that? Yes, you can. So the entire numerator turns out to be 9. What about the denominator? If you have 4 cakes and you take away 2 and 4/5 of a cake, how many cakes do you have left? If you have 4 cakes, all right, don't go that far and don't go that fast. If you have 4 cakes and you take away 2 cakes, how many cakes will be left? You have 4 cakes and you take away 2 cakes. How many cakes will be left? I'm looking for the answer in a minute. You have 4 cakes and you take away 2. How many will be left? Nice. Nice, very nice. So we see 2 cakes are left. No. Out of the 2 cakes that are left, you're going to take away 4/5. So how many cakes will be left? You have 2 cakes and you're going to take away 4/5. How many cakes will be left? Gee, I'm running at none. That's nice. I think that you're just being hilarious. If you have 2 cakes and you're going to take away 4/5, how many cakes will be left? No, I don't want any decimal. No decimal whatsoever. None. No decimal. I like that. I like that answer, a quarter. I like that one, a quarter. The person who said a quarter, think about it a little bit more. Those students who say a quarter, think about it a little bit more. You have 2 cakes and you take away 4/5. Of course, students. Of course. Students, if you have 2 cakes, I'm going to put the 2 cakes here. There are your 2 cakes. If you take out 4/5 of one, you take out 4/5 of one. You're going to have an entire cake left. And then you're going to have 1/5 from the other one. If you have 2 cakes and you take away 4/5, one of the cakes will be untouched. So this one will be untouched. And then you have 1/5 left. So it's going to be 1 and 1/5. Now student, this is something that you should be able to work out in your mind. Because 4/5 is less than 1. So if you have 2 cakes and you take away less than 1, it means that you're going to have 1 and something else. You have to reason up now, students. You have to reason up and you have to be practical. If you have 2 cakes and you take away less than 1 of the cakes, the amount that you take away is less than 1. It means that you're going to have an entire cake left and another portion of it. One and 1/5. Let me do something here. 2 minus 4 over 5. Alright? Students, there are many ways that you can do this. I'm too close to the camera. Students, there are many ways that you can do this. Now students, 2 is 2 over 1. 2 is 2 over 1. And if you want the 1/5 to go with the 1/5, then you have to multiply the numerator by 5 and the denominator by 5. So you get 10 over 5. 10 over 5. Then what do you do? 10 over 5 minus 4 over 5, that is going to be what? 6 over 5. 5 into 6 is 1 and remainder 1. So it's 1 and 1/5. There you have it. Students, be attentive because on the side I might put a simplification problem. Yes. Okay. All right, so let us do it in another way. Look at this one now, students. This one is even nicer. This one is even nicer. What? You see this one? This one can be rewritten. Let us write 2 as 1 plus 1. Okay? 2 is 1 plus 1. Take out the 2, put 1 plus 1. Take this one, put it back down here. Take this one, write it as 5 over 5. What were we doing? We were taking away 4/5. Sorry. It's 4/5 that we were taking away. We're taking away 4/5. So this 2, we write it as take out the 2, it's 2 is supposed to be there. 2 is supposed to be there. Then we take out the 2. And 2 is what? 1 plus 1. That's 2. 1 plus 1, that's 2. This one now, we're going to write this one whole as 5 over 5. Because 5 over 5 is 1 whole. Then what do we do? The 1 goes back. And then we have 5 over 5 minus 4 over 5. And that is going to give us 1 over 5. So it's 1 and 1/5. So let us finish this problem very quickly, students. 9 over 1 to be divided by 5 ones 5. 5 ones 5 plus 1 6. So it's going to be 6 over 5. And then what do we do? 9 over 1 multiplied by 5 over 6. You simplify that by a common factor of 3. 3 into 6 is not 1. 3 into 6 is 2. And 3 into 9, that's 3. And then that is equal to 15 over 2. So that is 15 over 2. Now, students, I am not gone. I'm going to give you a few seconds or even minutes to look at this screen. Look what we have there and make sure that you internalize them. Students, please have some patience with me. Do not forget that although we started early, there was a period of time although we started early, there was a period of time that we lost about 45 minutes. So please, students, let me see if I can do some more justice to these problems, these fraction problems, before you go. still here and attentive because I'm going to put some more on the board. Students, believe me, I have a major setback this afternoon. Not just because of what we see or did not see on the screen, what is this? Drag it? All right, so let's continue. That's number 6 and number 7. I'm going to be, yes, I had a real setback. I'm happy though that it happened. Seven, 8. So let's go for number 8. 3 and 2, 7 plus 1 and 2 thirds. Three and 2 sevenths plus 1 and 2 thirds to be divided by 1 and 1/7. 1 and 1/7. Students, I hope that you recognize ahead of time that this problem is already simplifying itself. Because the common denominator here is going to be 21, and then this is a 7, and when you do the reciprocal, the 7 is going to go to the numerator, and the 7 is going to go into 21 and simplify. That means that you're exercising what we call sequential logic instead of combinational logic alone. So let's go. 7, 3, so this is going to be 23 over 7 plus, it looks horrible now. 3 1 3, that's going to be 5 over 3 to be divided by 8 over 7. So we're going to have, since there's no common prime factor in 7 and 3, there's no common prime factor here. So what do we say? 21 goes there. 7 3 is 21. 3 times 23, 69 plus 7 5, 35. Oh my, that's a horrible thing. No, students, be very happy when you see the numbers getting large and uncontrollable. Be very happy. See how that number look big? Yes, I'm happy to see that number. Yes, I'm delighted. So we're going to divide this by, no, we're going to multiply because we have it already. So we're going to multiply this by 7 over 8. Very nice. Now students, look at this number. 69 plus 35. 104. And that's over 21 to be multiplied by 7 over 8. Now students, what will be, we're not using a calculator, and students, when you're solving a problem, I see people writing like 1.2 and those things. Students, when you're solving problems, fraction problems for your examiners, don't do that. They're going to give you an instruction. Write the answer in a fraction in its lowest terms. That's what they're going to say. Write your answer in a fraction in its lowest terms. So if you give decimal, you must lose marks. So if you get a fractions problem and when you finish, you write this 1.2, you must, well, you not get it wrong, it is a correct answer, the answer is correct. But you have to follow instruction in the examinations. The greatest reason for students not doing as well as they should in an examination is failure to follow instruction. Let's continue. Now students, it's a long shot for some students to say 8 can go into 104. Well, you can attempt it, and we'll show you what that means in a while. But I'm going to show you a little strategy if you exercise your familiarity with numbers. So let us look at that. Now students, look at this. Why am I doing it? 4, 8, 12, 16, 20, 32. That's nice. All of those numbers are multiples of 4. 4 divides into them without a remainder. They are divisible by 4. All of those numbers. Now, notice that of all of the numbers that are divisible by 4, every other one is divisible by 8. Every other one is divisible by 8. Every other one is divisible by 8. So if you land on a number that is divisible by 4, but it is not divisible by 8, it means that the one that follows after it is divisible by 8. Because what? Every other one is divisible by 8. Every other one is divisible by 8. So let us look at 104. So we're going to look at 104. It is the one just after 100. So the question is 100 divisible by 4? Yes, it is divisible by 4. But is it divisible by 8? No, it is not divisible by 8. That means the next one after it has to be divisible by 8. So this one is divisible by 8. If you understand the concept that I'm trying to put forward. How did I get 67 up the top? I hope that I don't have 67 up there. I'm hoping that I don't have 67 there. It is not far-fetched that I would write 67 and not even recognize it. That happens to me sometimes, but it's not there. Oh yes, it is there. 67. I hope that this is the one that you're talking. It's a 9 right here. I'm going to look and see what you are seeing. Oh, because of the light that is there, it looks like a 7, right? And don't ask me how I get a number there. Just tell me that the number is incorrect. I'm not going to answer you again if you ask me how I get a number there. Just tell me that the number that I have there is incorrect instead of asking me how I get it. Tell me that it is wrong. Tell me that I've made a mistake. Okay, it is actually a 9, but because I'm looking at your screen, right, what you are seeing, and it is right in the middle of the light, so that is why it looks like a 7. But it's actually a 9. So that is how you could figure that 104 is a multiple of 8. Every other multiple of 4 is a multiple of 8. So 100 is your number. It is a multiple of 4, but it is not a multiple of 8. That means the one that is following after it must be a multiple of 8. And of course, if you do your division right, 8 into 10, 8 into 8 is 1. 8 into 10 is 2. 1. Let's go, 1. 8 into 10 is 1 and carry 2. So remainder 2. So 8 into 24 is 3. So 8 into 104 is 13. And this should not be 2 but 21. That is the one that you should ask me how I have the 2 there. That should not be 2 but 21. Nice. And then, what next? 7 into 7 is 1 and 7 into 21 is 3. So your final answer is 13 over 3. And I'm going to be looking at number 9. Yeah, so that one is 13 over 3. Number 9. 5 and 4 6. 5 and 4 6 minus 4 and 2/3 all over 3 and 2/3. Students, right away you should see quite a few things that makes that one very simple. What is, I think I should put it right there now. I'm going to put number 9 down here. Follow me, students. It is highly unlikely that I could solve this problem here, but let's give it a shot. Let's go. Now, students, do you recognize that 4 over 6 is the same as 2 over 3? Can you see that? That 4 over 6 is the same as 2 over 3? You better be able to see that. Can you see that 4 over 6 is the same as 2 over 3? Exactly. All right. So the problem is finished, students. We don't have a problem left. Now, 4 over 6, 2 into 4 is 2, 2 into 6 is 3, 2/3. So 4 over 6 is the same as 2/3. So students, here we are going to say 5 minus 4 is 1. 5 minus 4 is 1. And then what else? And then this is 2 over 3 minus 2 over 3 will take care of itself. So 2 over 3 minus 2 over 3 is 0. They have a cancelling effect on each other. And then 5 minus 4 is 1. So the numerator is 1. Because 4 over 6 is the same as 2/3. So we are saying 2/3 minus 2/3, that's gone. And then 5 minus 4 is 1. And then what do we have after that? 3 is 9 plus 2. 11 over 3. Now students, please. See this. See this. See this, students. 1 over any number is the reciprocal of that number. So 1, if you want to write the reciprocal of 4, you write it as 1 over 4. If you want to write the reciprocal of 5, you write it as 1 over 5. If you want to write the reciprocal of 6, you write it as 1 over 6. So 1 over any number is the reciprocal of that number. That means 1 over this fraction is the reciprocal of this fraction, which is merely 3 over 11, and the answer is that, and we are finished. I'm not gone away. Now students, you will have to, this class should have been finished at 8, but please give me until 8:30. I will not go beyond 8:30. I need that individuals need to go to bed. I don't even have a phone to tell me the time. That's how disastrous my experience was this evening. Because my phone is blank, the screen is blank at the moment. And then we have daylight saving time and times in different parts of the world on the other screens. So we're going to look at number 10. So what I'd like to do by 8:30 is go across the board and then go across again, 9, 10. If I can. Yay! 1 over 5 times 3 over 10 times 3 over 10, and that is going to be all over 2.5. And you know that 2.5 is 5 over 2. So what do we say now? We can simplify this very quickly, students, because we have what? 3 over 50. 3 over 50 to be multiplied by, what is this? This is what? 2 2's 4 plus 1, 5. So you're going to think that it's going to be what? 5 over 2. But you have to do, because we are dividing by this, it's not going to be 5 over 2, but 2 over 5. Remember now, students, that we are dividing by this, which is 2 2's 4 plus 1 is 5. So it's 5 over 2. We are dividing by this, so we multiply and do the reciprocal. That is how we end up with this 2 over 5. And of course, you can see what that is immediately. 2 into 2 is 1, and 2 into 50 is 25. So this is going to be 3 over 125. So that one goes down very quickly. And number 11, 3 and 3 over 5 times 1. I don't want it to go too wide. 3 and 3 over 5. Multiply. We like to multiply very quickly because we know how quickly it simplifies. 3 ones 3 plus 2, 5 over 3. Then we are going to minus 2 and 2 sevenths. Nice. Let's go. Improper fractions. 5, 3, 15 plus 3. 18 over 5 multiplied by 5 over 3. And I think that we'd be delighted to simplify this to just 6. And we're going to be subtracting 7 2s 14 plus 2, 16 over 7. Not too bad. So what do we have? Look at this now, students. Please pay attention to this. Please pay attention to this. You're going to recognize that this is going to give you 6. Just 6. Because we are going to say 5 and 5 is 1, 5 and 5 is 1, and then 3 into 3 is 1, and 3 into 18 is 6. Put it right there. So it's going to be 6 times 1, 6, over 1 times 1, it is 1. So this turns out to be just 6. Students. Because it turns out to be 6, students, it just turns out to be 6. Then why would we just use 16 over 7? We'll not use 16 over 7. Because this turns out to be 6, we'll go back and write it this way again. Write it in the original form. Minus 2 and 2 sevenths. Nice. So let's see what we make of it. 2 and 2 sevenths. We go back. 6, you can subtract that in your mind. That is very simple for you. First of all, 6 minus 2 and 2 sevenths. What do you say first? 6 minus 2. What is 6 minus 2, students? Lovely. I see some students putting up 4 immediately. Yes, that's nice. 4. Now, students, if you have 4 things and you take away 2 sevenths, how many will be left? If you have 4 things and you take away 2 sevenths, how many will be left? You have 4 things and you take away 2 sevenths, how many will be left? Exactly. So you're onto it. So first thing we do, we say 6 minus 2, and that gives us 4 wholes. Then we're going to take away 2 sevenths from one of them. Take out 2 sevenths. 2 sevenths is this part. So let us take it out. That. So we're going to have what? 1, 2, 3 left, and the 5 sevenths, because we're taking out 2 sevenths. So this is 5 sevenths that is left here. And then we have 1, 2, 3, and 5 sevenths. So we have 3 and 5 sevenths. Students, write it as a single fraction in its lowest term. Sometimes that's what they want. So that 7 3 is 21 plus 5, 26 over 7 in the end. Now, students, If I work out every single one of them, then you will not have any to do, and you are going to be disappointed in me. So number 12, 2 and 2/3. I'm looking for a particular problem. I hope that I encounter it before we are through today. 2 and number 12. 2 and 2/3 minus 1 and 5/6. Minus 1 and 5/6 all over 2/3. Nice. So what do we say now? That's going to be 8 over 3. 3, 2, 6 is plus 8. 8 over 3 minus 11 over 6 to be divided by, students, let's not be too stingy to ourselves. Let's not be too mean to ourselves. If you're dividing by 2 over 3, we are multiplying by 3 over 2. Come on. We're dividing by 2 over 3, so we're multiplying by 3 over 2. Students, remember how we can do this in one step? This is 16 over 6. Because we're going to multiply both numerator and denominator by 2. So it turns out to be 16 over 6 minus 11 over 6. So it is 16 over 6 minus 11 over 6. And 16 minus 11. So we're going to have a 5 over 6 times, I'm going to put it over some more. So we have 5 over 6 multiplied by 3 over 2. And that's what? Over 4. Verify that with me, students. That's 5 over 4. 13. Yeah. We have some nice problems here. I like number 13. I'm going to try to do it right here. Number 13. 1 over 7 plus, in brackets, 1 over 7 plus in brackets, that's nice, 2 over 3 to be divided by 11 over 12. That's a beautiful problem. 1 over 7 plus 2 over 3 multiplied by 11 over 12. Over 12. So it's going to be 12 over 11. So let me have that right. 1/7, 2/3 divided by 11 over 12. So when we are finished, we have the 1/7, the 2/3, and then 12 over 11. Very nice. So what do we say now? 1, 4. So we're going to have 1 over 7 plus 4 over 11. And we know what that's going to be. I'm going to write it. 1 over 7 plus 4 over 11. Seven, 11, 77. 1 times 11 is 11. 7 fours, 28. And that turns out to be what? 39 over 77. Now, students, the one that we're going to be doing now is a regulation problem. What do we mean by regulation? the numbers will take care of themselves, as you can see. So we're not going to have much difficulty. But let's go. Number 14. 2 1/3 minus 1.5 over 1 5/6. So what do we have? 3, 2, 6 plus 1. 7 over 3 minus 2. Well, this is 1.5, so we know it's 3 over 2. 1.5 is 3 over 2. And we're going to divide this by 11 over 6. And of course, it's nice because you could see the 6 early and you could see the 6 by the common denominator here. And you know that they are going to eliminate each other. So you know that the problem is going to have a simplified answer. What is no, sir? Tell me which one do I need to take a look at. Students all, do not forget that I'm going to show this solution of these problems as much as I can. I'm going to post them. Six 1 6 plus 5, 11 over 6. I hope that this is the one that you're speaking about. Is it that one? Yes, students, I'm going to post those. Number 13. Is this correct? So, the person with the discrepancy, I saw you there, so I'm just inviting you to come and tell me what you saw. Or if you have the difficulty, then speak to me. So I'm inviting you in. Let's continue. We know that these do not have any common prime factor, so that it's going to be 3 2s, 6. 7 2s, 14. 3 3s, 9. To be multiplied by 6 over 11. And we can see the 6 going away already. Let's not be in too much of a haste. 14 minus 9. That will give you 5. So it's going to be 5 over 6 multiplied by 6 over 11. And these will go. And your answer is 5 over 11. Well, thank you very much. One is saying it does not look right. All right, so that's fine. So it does not look right, but I'm looking for, oh yeah. So I'm inviting you in so we can discuss it a little bit more. Yes, I've invited you in so we can discuss it a little bit more. All right, so let's go.
Good night.
Good night.
So, the 2 over 3, where the 2 go, sir?
It's here. Okay,
Yeah, but I'm not seeing it in underneath the.
okay, it's not in there, right? Right. So it is 8 over 11, correct?
Yes.
It is 8 over 11. Nice.
Yes.
Nice.
But you have 4/11.
So it should be 8 over 11. Does not say, but okay, no worries. But let's work it out the same way. So in the end, it should turn out to be 11:56. And then this will turn out to be 67. That's right?
Yes.
Very nice. Very nice. That's what everybody was badgering me about. Right. Yes, don't be afraid to say we have to change it to something else because this 2 was neglected. Instead of saying 2 times 4 is 8, we did not see this 2 and we put the 4 right there instead. Right, there's no difficulty with that. And thank you very much for pointing that out to me. Now, let me take a look at it over here because believe me, we had some difficulties at the beginning. Oh, we just have 3 minutes left. So what I will do, someone will remember that we ended at number 14. Yes, someone will remember that we end up at number 14. I wanted to do some more, but I cannot. I'm not gone. I cannot because run away because I need to discuss these with you. That's the first thing that I want to say. Yes, and I'm sure that that's correct. Yes. The first thing that I want to say is that do not forget that class will be tomorrow evening again, correct? Yes, it is. Tomorrow evening at 6. So it is Monday, Tuesday, it is Sunday, Monday, Tuesdays, and Thursday. Now students, what's this? This is your instructional manuals. The instructional manual that we are on is this one, which is algebra. So we are on algebra. For YouTubers, we are on algebra. So algebra, this one that we are on. Students, apart from purchasing the resources, you know that the class is free, and you don't have to purchase the resources, but you will be at a great advantage if you do this, because all that I'm teaching on the board, they are inside of these books. I'm leaning to one side because of how these books are heavy. So what we are doing, everything that we are doing for the entire year, they are in this book. We are at algebra in our instruction. In our tutorial, we are at tutorial 1. Tutorial 1, I showed you just now, but I'm going to show you the answer book. The answer book for tutorial 1 is this. So everything that I'm doing on the board, we have the answers in this book. This is the tutorial 1 answer book. And this is the question book that I'm using. Yes, this is the book that we are using. That's a nice question. If I still teach mathematics, of course. That's what I'm doing now. Because I'm doing another project, so I will not be able to do early in the afternoon, so I put it late in the evenings. So we put it at 6 to 8. We are going over to 8:30 because today we have some serious mishap. Right? So I think that we're about at 8:30 now. But I'm introducing the resources to some of the students who are not privy to them. So we have all of these books, students, and we are using all of them this year. We use them every year. And of course, we have the rest of your instructional manual apart from algebra. We have functions part 1. I don't know if I turned the book upside down, did I? Yes, I did. So we have functions part 1. We have functions part 2. We have functions part 2. We have computations part 1. It's right side up, I think. Yes, computations part 1. We have computations part 2 and geometry. We have trigonometry, the greatest. Trigonometry. And what do we have left? Vectors, matrices, and transformation. We also have your final examination preparation resource books. Your paper 2. So this is your paper 2 solution book. And of course we have the question book. And of course, this is your key. Students, when you have this book, you cannot fail. You're not going to get a distinction by this book alone, but you cannot fail. This is your paper 1 practice. Now students, this is the one that we are working with. This is the one that we're going to go into tomorrow evening. So we're going to go this, and then we're going to finish the first topic. Now students, what is typical of my resource books is that when you start this book, it starts as your normal book with your introduction, with your topics. Nicely, everything is done like it is done with a computer. It is really done with a computer, sorry. It is done with a computer. Everything is done like it's done with a computer. But when you get to the answer part of it, the answer part is not done with a computer. The answer part is done with the hand. So you can see the lovely handwriting there in your answer sheet and your answer part of the book. It's your instructional manual, but the exercises, you have the answers there. Now because it's late, that's why I'm speeding up so much explaining about the books. So if you want me to move a little bit slowly with the books, I think that I will do that for you when you join the live broadcast tomorrow at 6 p.m. I think that I will take the time at the end of the lesson, because I think that we have gone through a few portions of the lesson already. And so tomorrow we'll not have the entire lesson to go through. So we'll take a look at that. That meaning we're going to be taking a look at the resources again. And students, we have resources for students who are doing more advanced mathematics like CAPE Unit 1, CAPE Unit 2, CAPE Integrated. Right? Yes, I can speak for these books because they are being used in the institutions. Not only that, but I have written all of these books by myself. There was nothing downloaded from the internet. All diagrams were drawn, everything. There's no copy image or anything like that. I cannot afford to do that because I have to animate them. So I have to be able to manipulate those images for the animated audio visuals that you see. Now, is there anybody here doing additional mathematics? Anyone doing additional mathematics? And you do not have resources? You know that I have resources for additional mathematics. I see a lot of things to X out inside here. 0 minus. I'm afraid to click on some of these things that I see here. Right. So students, prepare yourself for class. Read over. Read ahead in some things. Do your homework. And please don't tell anyone that I didn't give you any homework. You have the tutorial book. And I've done what? 14 of the problems. You have the rest of them you can do. And you can go into tutorial 2. When you go into tutorial 2, you'll see all the problems there. And when you do your algebra, you have your homework. Don't tell anyone that I'm not going to give you any homework. because you have the books, so you have the homework already. I'm not going to give you any homework. And when the parents say, no, Mr. James did not give me any homework because all of the homework is inside of all of the books that we have. Your algebra book, as soon as you finish that topic, you do the homework at the end of the topic. And so on. So I hope that other individuals will be what? Interested in the resources, because when you have them, you are at an advantage. When you do not have them, you are at a disadvantage. You do not want to prepare for an examination without an advantage. Okay. Now, I thank you all very much for being here. Inside here, I see that I have 17 individuals. That's a small number. Yes, that's a small number. But I see there that I have over 1,000 views. I don't know what that means. And the heart should seem that I have a lot of likes. And that seemed to be 3,029. But as you imagine, you know, some people are just going to TikTok and they'll tell everything and what they mean. It will take me long, and it's not because I'm slow. It's because I'm not focused on those things. I'm focusing on teaching mathematics on TikTok for free. That's what I'm focusing on. So when I get inside here, TikTok is telling me that I should say something, I should ask for something, I should ask you to do this, I should ask. Me no know that. If they want to kick me off, then kick me off. That's not what I'm here for. So I'm not going to ask you to do coin, do this and send this and heart and roses and this and all of them kind of something. I know that. And that me come here for. I'm just getting onto TikTok and teaching mathematics, so as many of you want to join, that you can join. Yes. And that the entire world will learn mathematics from me somehow. Thank you all for participating. Thank you all for your feedback. And thank you all for the correction. Some teachers, when the students correct them, they say, oh, I was just doing it to see if you are paying attention. No, I may make mistake. So any one of you imagine that you're not going to see mistake, or me can't make no mistake, nobody come in here. Because you think I may have halo over my head, I have white wing for my back. No, I don't have any halo, and I do not have any white wing for my back. Therefore, when you come here, it is natural for you to see a mistake from time to time, every now and again. Right? Yes, and when you see them, tell me that you see it on the board, and I will go inside just like I've just done, and I will do the correction just like any human being. Right? And you know when the class has come to an end. And again, I'm saying thank you for your participation. I'm very delighted, I'm happy for this class, for this one. I think that is one of the most interesting ones so far, and I'm very happy about it. And when you see the two hands going up and waving, you know that the live has come to an end. So it's goodbye, and see you tomorrow evening at 6 p.m. when we will continue our algebra, working with directed numbers, positive and negative numbers. So goodbye for now, and you know the next thing is that the live is gone off screen. See you tomorrow. You're welcome. Past student 2. Good night. And that's for Mr. Gordon. You're welcome. So somebody's just joining. That's nice. That's very nice. $3,000.